In this experiment, we're going to be assembling a number of electrochemical cells and developing the potential that develops between the two sides of those cells. So the first thing that we've got to do is almost a little bit of housekeeping. Each of our cells is going to need an electrode made out of 5 different metals. So we've got electrodes that are nickel and zinc and lead and copper and silver. Now hopefully these are all in the right bottle, but sometimes they get mixed up and sometimes you might mix them up as you're bringing them back to your bench. So let me just take a quick look at these and see if we can figure out how to distinguish them from one another. First of all, let's look at the easiest one to distinguish. I think it's probably this one. The one that looks like copper is copper. The other thing you might notice, stamped on the end of some of them, there is, in this case, Cu. So that's definitely a copper electrode. What about the other 4? The other 4 metals are all, well, metals that look like metal. So how do we distinguish between them all? Well, a couple little things. First of all, some of them do have stamps on them, but even if they don't, let's start with the easiest one. You're going to have a silver electrode. The silver electrode is probably going to be the shiniest of the bunch. It's also the thinnest of the bunch because, what do you think? Silver's probably more expensive than the other ones, so we're going to use smaller silver electrodes. Very thin, very flexible. So that's going to be your silver. Okay, we're down to 3. What about the other 3? Well, if we just kind of feel them, one of them feels a little bit different than the others. And that's probably your second shiniest electrode. That's the nickel electrode. I don't know that any of the nickels have Ni stamped on them, but the nickel electrode's usually pretty shiny, and nickel's pretty hard. You can bend it, but it's a little harder to bend than some of the other ones. That gets us to zinc and lead. And if you think about lead, it's not that hard to distinguish between these two because what? Lead is a very dense metal, and if I feel these two, well, this one's much more dense, it's much heavier, and lead is a much softer metal, so it's pretty easy to bend the lead electrodes. Now, it's not very hard to bend the zinc electrodes either, but I think you can probably figure out the difference between lead and zinc without too much trouble. The other thing you have to do before you actually use these is, especially if you look at something like the zinc electrodes tend to be a little dirty. So we need to clean those up a little bit. And to do that, we're going to use steel wool. So all you really have to do is take a little wad of steel wool, pinch the electrode between it, and pull it through a couple times. Don't lay these down on the bench and rub on them because you'll end up scratching the bench top all up, and you really don't need to do that. So I've just pulled this through, what, maybe a dozen times in each direction, and you can maybe see that it still looks maybe a little dirty, but it did shine up quite a bit. So that's how we can go about cleaning these electrodes. Now, what are we going to do with them? Well, in the first part of the experiment, we're just going to look at qualitatively how these different electrodes react with metal ions of the different metals. So that's going to be the first part of the experiment. I think that's pretty well explained, fairly easy to follow in the manual. After that, we're going to put together some half cells and some electrochemical cells and do some measurements. So let's take a look at that. So I'm just going to set up a couple of these. I've got zinc, copper, and nickel in small test tubes. I just cleaned the zinc electrode off, so let's go ahead and pop the zinc electrode in there. Copper electrode looks like an old penny. We want it to look a little bit like a newer penny, so let's clean that one up just a touch. And you have to clean both ends. One end's going to be in the solution, one end is going to be attached to your external circuit. So That's a little better. Doesn't have to be perfect, but a little cleaner makes it a little nicer. And nickel. Again, those nickel electrodes usually pretty darn clean. Doesn't hurt to give it one or two little swipes just to make sure that it's in good shape. So there are my 3 half cells. Now, what I want to do is get electrons to pass back and forth between these. In order to do that, well, I need a path for those electrons to follow. So we're going to use a salt bridge, and the salt bridges we're using are some plastic tubing, and inside this plastic tubing there is agar gel, an agar gelatin with ions in it that will serve as a salt bridge. So I'm just very gently cleaning that off. If you look at your salt bridge, it shouldn't look like there's anything in there. It should look like a solid tube. If you pick one out that's got a great big gap in it, it's not going to work. So look at one that's a solid tube, and there's our salt bridge. These need to stay wet, but they can be out of solution for a little while. So to start, let's measure our copper and zinc. So let's get the salt bridge down into the solution, down into the solution. So now I've got part of a completed circuit, but, well, this doesn't really make a circuit, this just makes a one direction. So what we need to do is complete this external circuit on these electrodes, and we're going to do that using a multimeter. Now, if you haven't used a multimeter before, don't be too intimidated. These aren't the most complicated pieces of equipment. There are a lot of settings and they can tell you a lot of information, but for what we need, it's not that big of a deal. So let's take a little closer look. First, let me hook this up. So I want to always hook the black lead up to whichever half cell is listed on the left in the table that I'm reading. So if I'm going to do zinc copper, I want the black to be hooked up to the zinc. I want the red to be hooked up to the copper. That should be good. Now let's take a look at our meter.